criticism of Fisher's quantity theory of money criticized by Cambridge economists. Next one, the cash balance approach. The cash balance approach is also known as the Cambridge equations. As an alternative to Fisher's quantity theory of money, Cambridge economists Marshall, Pigou, Robertson and Keynes formulated the cash balances approach like value theory. They regarded the determination of value of money in terms of demand and supply. Robertson wrote, in this connection, money is only one of the many economic things. Its value, therefore, is primarily determined by exactly the same two factors as determined the value of any other thing, namely the conditions of demand for it and the quantity of it available. The supply of money is exogenously determined at a point of time by the banking system. Therefore, the concept of velocity of circulation is altogether discarded in the cash balances approach because it obscures the motives and decisions people behind it. On the other hand, concept of demand for money plays the major role in determining the value of money. The demand for money is the demand to hold cash balance for transactions and precautionary motives. Marshall wrote with regard to the demand for money, to give definiteness to this notion, let us suppose that the inhabitants of a country find it just worthwhile to keep by them on the average ready purchasing power to the extent of the 10th part of their annual income, together with a 15th part of their property. Then the aggregate value of currency of the country will tend to be equal to the sum of these amounts. Thus, the cash balances approach considers the demand for money not as a medium of exchange but as a store of value. The Cambridge equations shows that given the supply of money at a point of time, the value of money is determined by the demand for cash balances. When the demand for money increases, people will reduce their expenditures on goods and services in order to have larger cash holdings. Reduced demand for goods and services will bring down the price level and raise the value of money. On the contrary, fall in the demand for money will raise the price level and lower the value of money. The Cambridge cash balances equations of Marshall, Pigou, Robertson and Keynes are discussed as: first one, Marshall equation. Marshall did not put his theory in equilibrium form, and it was for his followers to explain it algebraically. Friedman has explained Marshall's views thus: as a first approximation, we may suppose that the amount of one wants to hold bears some relation to one's, since that determine the value of purchases and sale in which one is engaged. We then add up cash balances by all holders of money in the communication and express the total as a fraction of the total income. Thus, we can write M is equal to KPY, where M stands for the exogenously determined supply of money. K is the fraction of the real money income, which people wish to hold in cash and demand deposits. P is the price level, and Y is the aggregate real income of the community. Thus, the price level P is equal to M divided by KY, or the value of money. The reciprocal of price level is 1 by P is equal to KY by M. This is Marshall equation. Next, Pigu's equation. Pigu was the first Cambridge economist to express the cash balance approach in the form of an equation, that is, P is equal to KR divided by M, where P is the purchasing power of money or the value of money. K is the proportion of total real income or resources which people wish to hold in the form of titles to legal tender. R is the total resources or real income, and M refers to the number of actual units to legal tender money. The demand for money, according to Pigu, not only consists of legal money or cash, but also bank notes and bank balances. In order to include bank notes and bank balances in the demand for money, Pigu modifies its equation as P is equal to KR divided by M into C plus H in bracket 1 minus C, where C is the proportion of total real income actually held by people in legal tender including token coins. 1 minus C is a proportion kept in bank notes and bank balances, and H is a proportion of actual legal tender that bankers keep against the notes and balances held by their customers. Pigu points out that when K and R in the equation P is equal to KR divided by M and K, R, C and H are taken as constants, then the two equations give the demand curve for legal tender as a rectangular hyperbola. This implies that the demand curve for money has a uniform unitary elasticity. Next, Robertson equation. To determine the value of money or its reciprocal, the price level, Robertson formulated an equation similar to the Pigu. The only difference between two things that instead of Pigu's that real resources are, Robertson gave the value of total transaction T. The Robertson equation is M is equal to PKT or P is equal to M by KT, where P is the price level, M is the total quantity of money, K is the proportion of the total amount of goods and services purchased during a year by the community. If we take P as the value of money instead of price level as in Pigu's equation, then Robert's equation exactly resembles Pigu's, that is P is equal to KT divided by M. This is Robertson equation. Next, Keynes equation. According to him, people always wants to have some purchasing power to finance their day-to-day transactions. The amount of purchasing power depends partly on their to hold money is given. This demand for money is measured by consumption units. A consumption unit is expressed as a basket of standard articles of consumption or the object of expenditure. If K is the number of consumption unit in the form of cash, N is the total currency in circulation and P is the price for consumption unit, then the equation is N is equal to Pk. If K is constant, a proportionate increase in N will lead to a proportionate increase in P. This equation can be expanded by taking into account bank deposits. Let K be the number of consumption units in the form of bank deposits and R the cash reserve ratio of banks. Then the expanded equation is N is equal to P into K plus R K dash. Again, if K, K dash and R are constant, P will change in exact proportion to the changes in N. Keynes regards his equation superior to other cash balances equation. The other equation fail to point how the price level can be regulated since the cash balances held by the people are outside the country. By controlling N and R, it is also possible to regulate bank deposits K dash by appropriate changes in the bank rate. So, P can be controlled by making appropriate changes in N, R and K dash so as to offset changes in K. Next concept, criticisms of this theory. Some other economists are not ready to accept these Cambridge equation theories. So, they are criticized like, this theory is truism. These equations are truism. Take any Cambridge equation, it establishes a proportionate relation between quantity of money and price level. Second one, price level does not measure the purchasing power. Measuring the price level in consumption units implies that cash deposits are used only for expenditure on current consumption, but in fact that they are held for a vast multiplicity of business and personal purpose. By ignoring these aspects, the Cambridge economists have committed a serious mistake. Next one, more importance to total deposits. Another defect of the Cambridge equation lies in its applying to the total deposits consideration which are primarily relevant only to the income deposit, and the importance attached to K is misleading when it is extended beyond the income deposits. Next one, neglects other factors. Further, the cash balances equation does not tell about changes in the price level due to changes in the proportions which deposits are held for income, business, savings purposes. Next one, neglect of saving investment effect. Moreover, it fails to analyze variations in the price level due to saving investment inequality in the economy. Next one, K and Y not constant. This is unrealistic because it is not essential that the cash balances and the income of the people should remain constant even during short period. Next one, fails to explain dynamic behavior of prices. It fails to point out the extent change in the price level as a result of a given change in the quantity of money in short period. Thus, it fails to explain the dynamic behavior of prices. Next, neglects interest rate. The relation between quantity of money and price level is not direct but indirect via the rate of interest, investment, output, employment and income. That is what the Cambridge equation ignores and hence fails to integrate monetary theory with the theory of value of output. Next one, demand for money, not interest inelastic. It means that money performs only the function of medium of exchange and do not possess any utility of its own, such as store of value. Last one is neglect of goods market. According to Patinkin, they led an undue concentration the money market, a corresponding neglect of the commodity markets, and a resulting dehumanizing of the analysis of the acts of monetary changes. These are the criticisms of cash balances approach. Next concept is index number. Index number measures and compares economic variables. It indicates percentage or ratio of changes in variables between two different periods of time. It measures relative changes in price, quantity, value from one period of time to another period of time. It calculates the ratio of the current year value with the ratio of base year value. The year with which the current year is compared is called base year. Index number is a specialized average designed to measure the changes in a variable with respect to time. This statistical device is used to measure the changes in the quantities such as prices, wages, cost, sales, production, exports, imports, etc. It measures a change over a period of time referring to a base year whose value is equal to 100. So, it compares economic variables of a particular group at two different periods. Next, steps to preparing price index number or methods to constructing the price index number. First method, purpose of the index number. Before constructing an index number, it should be decided the purpose for which it is needed. An index number constructed for one category or purpose cannot be used for others. A cost of living index of working classes cannot be used for farmers because the items entering into their consumption will be different. Next, selection of the commodities. Commodities to be selected upon the purpose or objective of the index number to be constructed, but the number of commodities should neither be too large nor too small. Moreover, commodities to be selected must be broadly representative of the group of commodities. Next, selection of prices. The next step is to select the prices of these commodities. For this purpose, care should be taken to select prices from representative persons, places or other sources, but they must be reliable. Then the problem is to select wholesale or retail prices. This depends on the types of index number. For a consumer price index, wholesale price index are required, while for a cost of living index, retail prices are needed, but different prices should not be mixed up. Selection of an average. Since index number are averages, the problem is how to select an appropriate average. The two important averages are the arithmetic mean and geometric mean. The arithmetic mean is the simpler of the test, but geometric mean is more accurate. However, the average prices should be reduced to price relatives either on the basis of the fixed base method or the chain base method. Next, selection of weights. While constructing an index number, due weightages or importance should given to the various commodities. Commodities which are more important in the consumption of consumers should be given higher weightages than other commodities. The weights are determined with reference to the relative amount of income spent or commodities by consumers. Weights may be given in terms of value or quantity. Next, selection of base period. The selection of the base period is the most important step in the construction of an index number. It is a period against which comparisons are made. The base period should be normal and free from any unusual events such as war, famine, earthquake, drought, boom, etc. It should not be either very recent or remote. Last one, selection of formula. A number of formulas have been devised to construct an index number, but the selection of an appropriate formula depends upon the availability of data and purpose of the index number. No single formula may be used for all types of index number. Next concept is simple index number. To construct a simple price index, compute the price relative and average them, add the price relative and divide them by the number of items. The formula sigma R divided by N. Here sigma is represents total, R is represent price in relatives, N is represents number of commodities. In this table, first column is commodities. We consider total 5 commodities, namely A, B, C, D and E. Next column is 2015 price. This is base year prices. 20 rupees per kg, 5 rupees, 15, 25, 20. Next column is current year price, that is P1. 25 rupees per kg, 10, 30, 30, 450. Last column is price in relatives. It is denoted by R. Price in relatives we can calculate with the help of current year price and base year price into 100. So, P1 divided by P0 into 100. Current year price divided by base year price into 100. 25 divided by 20, we will get 125. 25 divided by 20 into 100, we will get 125. Next, 10 by 5 into 100, 200. 30 divided by 15 into 100, 200. 30 divided by 25 into 100, 120. 450 divided by 200 into 100, 225. Total price relatives is 870. That is sigma R is 870. Using arithmetic mean, price index is 2020. Sigma R divided by N is equal to 870 divided by N. N means 5. 870 divided by 5 is equal to 174. When subtract the base year value, that is 100, in this answer we will get 74%. Means 174 minus 100, we will get 74. This is a percentage. It means the index of wholesale prices in 2015 comes to 174. This means that the price level rose by 74%